Okay, let's continue. Before we start looking at examples and looking at code, there's still a couple more things we want to try to understand a little bit better. And let's take just a few minutes here and consider the Android View class. So the class that you'll be extending to create what is essentially your custom view. That's this class Android.view, little view, big view. Here on the PowerPoint slide, here's a snippet from the API documentation. So what have we got here? The class represents the basic building block. So this is the building block for all UI elements, and you'll see this is really the root, the top of the hierarchy for all of the UI elements that we use in class and we use in developing our Android user interfaces. Goes on to say a view is a rectangular area on the screen. And what are the responsibilities of the view class? So drawing, and we're going to use that onDraw method, and event handling. Now here, this last little snippet, this is important to understand. View is the base class, so the parent class and an inheritance relationship, the base class, the parent class, the superclass, in an inheritance relationship for all of the widgets. What are the widgets? The widgets are all the all the UI components we use. Your buttons, your text boxes, all the things you've been using. Let me drag over here the API documentation. So here you see a public class view, Android. This is Android.view.view. I recommend you take a few minutes, look through this. There's generally some good information up at the top, and then you've got everything you wanted to know about view classes, all the way down to our list of properties and methods. So notice what happens here. Let's pull up a different page out of the API documentation. So here is the button class, and you've used, here you go, right here, Android.widget.button. You've used this many times. Note this information at the top here. This is the inheritance hierarchy. So we start with java.lang.object, and that's the way Java is architected. Java.lang.object, all classes, every class in Java is a subclass of java.lang.object. So that's just the way the Java language is architected. But notice here's Android.view.view. Then there's a child class, Android.widget.textView, and then Android.widget.button. So view is the base class for all of our UI components. If we go over here to text view, we see something similar, but here text view just is a direct descendant or a direct subclass of view. Here's another one called image view, Android.view.view. So Android.widget.image.view, and try this yourself. Just look up some widgets and look up some other widget types, and you'll see that the view class here is the base class for everything. Now, while we've got the API open, let's just take a moment and look through it. So, and there's a lot of information in here. Here's a summary of all the different nested classes. Here's all the XML attributes. So these are all things you can put in your layout file. You can see there's quite a few. Here's constants. There's quite a few. Here are some fields. Again, quite a few. Here are our constructors. So here we'll actually use, we'll use some of these constructors. Actually, we'll use this one right here in just a couple minutes, and we'll use some of these methods here. So here are all the public methods. One method that is critically important. Notice again, there are quite a few. Lots of G's, because that's the get. H-I, here you go. So here is a method called invalidate. Public void invalidate. Invalidate the whole view. If the view is visible, onDraw will be called at some point in the future. So I wanted to take just a minute to draw attention to this invalidate method. This is a very important method. What this basically means, invalidate the whole view. So what does that mean? It means that this will cause sometime in the future, not necessarily instantaneously, but sometime in the future, this will cause the onDraw method to be called. Recall from a little bit earlier, the onDraw method, you don't call onDraw directly. onDraw is called by the Android runtime. So what you do, if you want your view to be redrawn, you call this method invalidate. It's like putting in a request to the Android runtime. Please call my onDraw method. I have new information. Excuse me, I need to redraw my view. Now, just a preview of coming attractions. This invalidate method must be called from the user interface thread. Don't get too wrapped up in that right now. For the things that we're going to do here, it will be the UI thread, the user interface thread. Later, we're going to talk about Android threads and Android multi-threading. Then we will look at this method called post invalidate, which can be called from a non-UI thread and will cause the view to be, will cause onDraw to be called. Don't worry about it too much right now. So let's continue. And again, here's our basic model: public class myDraw extended view. So let's look at some of the nuts and bolts of actually using these. And I think you'll see it's pretty easy and it's a lot of fun. It's visual programming is fun. So the first thing we want to do is we want to create an Android project in the the usual way. We're going to create a project. We're going to have an activity. You want to add a view to your project, and there's a very easy way to do this in Eclipse. There's a wizard that will help you do this, and will create your skeleton view class for you. It'll create your stub. So in Eclipse, easy to do, and I'll do one in Eclipse in a couple minutes. But where you reach over, you do File, New, Class, and so this is, you want to add a new class to your project. Now, one thing you should do here, set the superclass. So here, right here, you need to. So you're going to have to give it a name. Call it My View right here. You want to set the superclass here, and the superclass is Android.view.view. And there's a couple other checkboxes. Go ahead and check constructors from superclass. What does that mean? That means the constructors will be included in your skeleton view class. You won't need to use them all, but they're in there. At least initially, you won't need to use them all. But initially, it's good to have them in there. You can go ahead and check this box, inherited abstract methods, as well. It'll just put stubs for the abstract methods from the superclass, which is Android.view.view. So go ahead and use this wizard. This is the new class wizard, and we're forcing it to create an Android view by specifying the superclass here. Go ahead and click Finish when you're done. So once you've done this, so what do you need to do? So you need to create an instance of your view. So you need to instantiate your view. And this first exercise we're going to look at, you're going to see how simple it is to create your own custom view. So we're going to go in. So given that we've created a new Android project, we have an activity, as we always do. We've just added a view. So we're going to go into the activity. And the first thing you want to do is you want to create an instance of your view. And you're going to have something like this. This example assumes that you've declared my view, this object, my view, earlier in the code. So we'll go ahead and we'll create an instance. Now we need to pass in, if you recall we looked at those view constructors, we need to pass in an object of type context. An activity is a context, so we can just simply pass in this. It takes an argument of type context. Activity is a subclass of context. So we'll go ahead and we'll do that. We'll create our view object, and then look how easy this is. Set content view, my view. So in the first example, we're not even going to have an XML. Notice what do we usually have here? We usually have our XML layout file right here. In this first example we're going to look at, where the view is going to take all the screen real estate, the view class. So we don't even need an XML layout file. Now we can use one, and I'll show you how to do that in a moment. But here is a very easy way to do it. Now, in the case where we do use an XML layout file, this should be very familiar to you. Nothing different here. In this situation, the view is actually contained in the XML layout file, and you can get a reference to the view in the normal way. Find view by ID, r.id my view. And in the XML layout, and I'll show you this in the very next slide, you refer to your view using the fully qualified class name, and you can use all the standard attributes that you're used to using in an XML layout file. So here's the situation where we have a view in an XML layout file. So what have we got here? This is a new kind of a layout, one we haven't looked at before. This is called a frame layout. And a frame layout is designed to block out an area on the screen to hold a single item. And I think you probably guessed it, our single item is going to be a view. And this is the case, why do we want to do this if we can just do the set content view thing? This is the case where we want to get a programmatic access to this view. So what will we do here? The frame layout, you can set the orientation to vertical. You want to match parent, so we're going to take all the screen real estate. Now here's the trick. The view in the layout, you've got to give it the fully qualified name of the class. And in this case, this is your package in the example that I'll give you out on Blackboard. It's com.is413.myfirstdraw.myview. So this is what's referred to as the fully qualified name of the class. Notice here we set the ID as per usual. The same with the width, the same with the height. So again, we give it the fully qualified class name. That includes the package and just the name of the class. Get the ID as per usual, and the width and the height The width and the height, match parent, we're going to take all of the screen real estate. So let's go ahead and look at an example. So we'll do that in the very next video.